All right, unfortunately, I just recorded two lectures that a part of my recording was cut off. Well, not cut off. I had like a big ass block here that was black and nobody could see the code. Unfortunately, two lectures gone. I have to redo them. Now this lecture is going to be namespace and templates. I will have to redo the try and catch, but it's gonna be a low priority since we're getting late on time. And if I get extra time, I'll make a video last minute for it. Now recording, not recording. According to recording, I don't even know what I'm saying at this point. But templates and namespace, how to use it. So now we're gonna use just the standard. Int main, and if you guys recall, we've always used std when we wanted to print out something, right? This green std. Why do we always have to do it? This is because if I remove this, the code is gonna be like, yo, what the fuck is this? I've never used this, I've never seen this, where do you get it from? And so I have to specify and I have to tell the code that this comes from this library, it comes from the standard library. And so when I do this, I am basically telling the code this will be found in the standard library, and this is called a scope operator. All right, so I'm telling the cout is found in the standard library. Now, do I have to write this every time I use something from the standard library? Yes, unless I use a namespace. And so there's something called using. This is telling the compiler what I'm using. So I can tell it I'm using cout. This is what I'm using. So now when I get rid of this, the compiler will know that I'm using this. And so it will assume, hey, this is from the standard library. But you see, for the endl, I didn't put it. So I could remove it and it'll still give me an issue unless I do the same thing, right? But obviously I don't want to do this for all of them, and my key just fell. There you go. I don't want to use it for all of them. Well, I'll have to do this for the sin as well and every other library I use. So the other thing I can use is something called namespace. And I can't believe I'm making a lecture on namespace because I tell everybody not to use a namespace like this. But anyways, when you use it like this, I will be saying everything I use that looks weird to you, compiler, go and see if you can find it in the standard library. And that's what it does, is whenever it sees a cout, an endl, a sin, we'll go and find it in this library. Now, how can I make my own namespace, and why would I want to make my own namespace? So let's assume I make two functions. One will print me a number, but I will print it differently. So this is going to be void. Whoops. There you go. And let's say I want to use this differently. And so we'll make one print out just the number, and one will print out the message and the number. And so this will print out just the number. I don't know why this is in red. What's wrong? I think that's my compiler tripping. There you go. And so now the thing is, this one is going to print a message that's going to say hello, and then it will print out the number. Okay. Now, what's the difference? We'll make this endl, so it's a whole new line. Now, what's the difference between these two? Obviously, nothing. When I run this function and I say print, why is my code tripping? That's kind of tripping me out now. And not overload functions distinguished by a return type alone. Okay. Anyways, so yeah. When I call this function and I pass it 5, the code is not gonna know whether to run this or whether to run this, and that is why you'll need the namespace. So let's comment this out just to make sure my code is not tripping. Okay. Yeah, so it works. It printed hello, then it printed the number. I don't know why it's underlined, just ignore that. So now when I do this, and I have two of the same, and I run it, it gives me a error. It says, hey, yo, you have two of these. What do you mean? What the hell, man? And so I'll have to tell it to differentiate. Now, if I make this a different variable, it still can't differentiate because it goes by the integer. And so if I make this a string, it will differentiate that I'm putting an integer, and therefore we'll use this one instead. All right. And so what if I want to make this automatic, right? And well, not automatic. What if I want to differentiate between the two? I still want to pass both of them an integer, but I want one to print this and one to print this. What can I do? And this is where namespace come in. I can say namespace, and I can name my namespace. Let's say my namespace is gonna be just num, right? And so what this is saying here, I can differentiate between the two. So I can say your namespace, and I can say message num, right? And so you see here, now the code, it still doesn't differentiate yet, but the function doesn't even exist now. So if I just do this and I run it, you see, it'll tell me, hey man, what are you using? And so I'll have to specify which one I'm using. So I can say just num, and I'll use the scope operator. And now I'm telling it, go to the just num namespace, and inside there you'll find this function. So you see now when I run it, it knows exactly which one to use. And now I can change this, and I can say message num, and it will still know exactly which one to use, right? And so can I have one namespace within the other? Yes, you could. And you see here, I'll do it actually. So I can say namespace, Facebook. And now I have a namespace within a namespace. So you see when I run this, it gives me an error. Ayo, what are you talking about? When I give it Facebook as well, I'm telling this print is inside Facebook, which is inside message num. And I print this, it works. All right, because it is. This is inside Facebook, which is inside num. All right, now another syntax you could do instead of this, and this is for C++ 17, I think, compiler 17. You can also do it like this, where it will also use this as double namespaces. So this is also valid. Now this is all there is for namespace, really. I could put a function here. I could put two classes of the same name, but they're different classes, and I can specify using a namespace which class I'm talking about. All right. Now we're going to go through templates, and we're going to actually use the same thing. Well, not the same thing, similar code. This code we don't need. We'll just keep this one. And here I'll just print 5. And so right now, if I run this, obviously it should run just fine, and there's no issues. Let's remove this and use my std. There you go. Now, what if I wanted to print a string? What if I wanted to do print, and I wanted to say hello? Now, if I run this, obviously it won't run. It'll be like, hey, you're passing me a string. I expect an integer. So can I just... right? Wait, why is this not working? Oops, semicolon. And see now, it will work for both, because this one it will associate it with an int, and this one it will associate it with a string. And this is not because it's in order, because if I take this and I put it up here, this will still work. It's just the compiler can identify this as a string, and it can identify that it has a function with the same name that takes this signature, and so it knows what I'm talking about. All right. Now, what if I want to pass a float? Do I have to create another one with the float? Obviously, this is hideous and it's too much work. I can write one function, and I can use template. Now, template, this will always be the same. It will not change. Whenever you want to use a template, you'll put template. Now, inside here is what differentiates. You can either put namespace, not namespace, sorry, type name, or you can put in class. They both mean the same exact thing. I don't use class because obviously this is the same thing as making us class like this. I don't want to confuse people, and it's also weird. Type name is much better and it's clean. Now you can put anything. You could say name, you could say value, oh my god, value, you could say type, you could say anything. I'm gonna keep st. Now what does t represent? T represents what I'm putting in here, the type, this type. And so here, if I put in here t, this template, what it does is if I don't use this, if these don't exist, this whole thing doesn't even exist actually. So even if I make a mistake, and let's say I make it look like this, obviously, if I run this, it doesn't compile. But there are other things that actually will work, even though they shouldn't. And so we'll go through an example. Technically, this is not supposed to work. This is supposed to compile, but it depends on the compiler. So we'll use another example where it shouldn't work. And then I'm going to use a class student. And I'm going to make an int array of size. I'm not sure if this would work. Maybe it's because of my compiler. Let's just test it. If it does work, then it's fine. But if it doesn't work, that's because my compiler is tripping. So we'll see. I'm not gonna set a getter. I'm just gonna leave it as is for now, actually. And compiling this, as you can see, actually didn't work. But usually, if you have not a messed up compiler like mine, this would work. And you're gonna think, why does this work? Is because this template doesn't exist unless I'm making the class, which I'm not. And so the same thing here, this doesn't exist unless I run these functions, which I'm not. And so why is that? Is because this template just keeps this word, just keeps the wordings of this. It doesn't create it. And then when I call the function, when I call these functions, what it will do will be like, oh, my print is getting called. The template will take this, create it on its own, and I'll be like, oh, this is a string. Let me replace this with string. And then I'll create another one. I'll be like, oh, this is an int. I gotta create one with an int. So you see how before we did it manually? Now this template does it automatically. And that's why templates are great and they're very useful and they come in handy and they're very powerful. And so you see now when I do this and I run this, it will automatically print both, even though I wrote only one function. Now what else can you do with this? I can specify here an int type n, let's say, and I can use this n inside here, right? And so that's another way I can do it. Let's do a class example. And so let's make a class student. And inside this class, I'm gonna create, like I did earlier, I'm gonna create a private array. And this array is gonna be an integer type array with some size. All right, and then private here, I can create, well, I'm gonna get a getter, and this getter will be a pointer because arrays are a pointer. And so I'm gonna say get array, and this will just return me my array. Nothing too special. I make so many typos. I'm not used to this keyboard, but anyways. So now what I could do is create my student. Let's say Joe. Joe is my student now. Now, if I run this, let's see if it works. Actually, this size is not even defined. So let's put it as size. There you go. So even now my size is defined, it still doesn't run. Well, actually, this is because of Joe. Why is Joe not running? No instance of constructed student matches the argument. Excuse me, sir? Well, I think it's because the template is missing right now. So let's put this without the template first, and then we'll do it with the template after. You see, now we created a student Joe, and everything is compiling just fine. The first thing I'm going to start playing with is, what if this array, I don't want it to be an integer? What if I want to change this according to my student I'm making? And so maybe one student I want to put his grades, maybe one student I want to put his courses. I want this array to change size, to change types. And I could do that using a template. And so in this template, I'm going to say a namespace, or sorry, not namespace, type name t. Now instead of this, I'm going to put t. Now I don't have to put t, I could say this is type, and I could put here type. And you see now, if I compile this, it doesn't run. It says the template argument. So what this is expecting a type. When I'm creating a student Joe, I'm not passing a type. How do I pass a type? You just do this and you put the type here. So if I want an std string, this will create an std string here. And see when I run this, this will compile, and this will be now a string array. And if I change this to an integer, this will now compile and create an integer array. Now what about the size? Can I determine the size? So I could do the same thing here, and I could do, let's say, an int size. Remember, size will always be a number, so I did an int, and there's gonna be size, and I can specify that here. And so let's say I want it a size 5. Compile, compiles fine. Let's say I want a size 10. We'll compile just fine. What if I want an std string of size 10? Same thing, we'll compile just fine. Now one thing though, is, what if I wanted to access this get array? All right, let's say I make an int, let's say int array, and I want this array to equal the Joe get array. So Joe.get array, and this might have to be a pointer. Joe. Inaccessible. Why is it? Oh, it's private. Public. There you go. And so now when I compile this, return array, and as you can see, what is the issue here? Here I have an std string of size 10. So std string of size 10. And here I'm trying to return an integer array. All right, I'm trying to return an integer array. So in order for me to make it dynamic with this, I can also say this is a type. And so when this changes to a std string, this changes to a std string. And when this changes to an integer, this changes to an integer. And now I can actually return this. But obviously, since this is an std, I have to be expecting a string pointer. And now when I compile this, what did I miss? Semicolon. There you go. And as you can see, it compiles just fine. And so can we do this for classes, functions? Can we do it for variables? And the answer is yes. You could also do this for variables. You could do this. You can make a template for almost anything. And that's what makes them really good and really powerful. Now, even for the size wise, I do want to test something and see if I remove this, will this run? Yeah, that's what I was trying to get at before, but I don't know why it didn't run. See, now this runs. Even though, so you see, I'm going to copy this exact same code. And watch what I'm going to do here. This is a student. I'm going to make it students, just so I differentiate from the top one. Here, let's say I do an int. And here, let's say I do an int. Right? Now, what if I do this? And I pass that size like that. You see, it doesn't even run. It says the array was not declared in the scope. Wait, I might have messed this up somehow. Whoops. Well, this is actually the error I was trying to get on. But yeah, so as you can see here, I'm passing it's the same code, except this one has a size, and this one, well, this one, they both have a size, right? And you see this one, if I remove this, and let's say I create an empty right now, not even a size, I'll leave it empty. And if I compile this, still same issue. It says an otherwise empty class student. Like, what is this array? But here, I didn't pass it anything. You see here, like, when I create this, I'm not passing nothing. This still compiles. And that ties with the point I was making earlier, is that this doesn't exist unless I make it, unless I use it. And I do like student Joe, unless I do this, and I specify, hey man, I want an std string, let's say I want actually an int with size 10, then what it does is it will copy this whole thing here, and we'll do, okay, int size 10, and this is int. And this is what the template does. It will recreate one. And so that's what makes it really powerful. And that's really all about templates. If you remember, when we were using vectors, include, and then see how I use vector. And then here, when I do vector, remember how I said you have to say the type here and you say the name here? Let's say vector, Jesus, or actually array. There you go. And you see now, this does that not look similar? And it does. Well, obviously here I need my std, but this looks the same as this. And that's the whole point. This is also using a template. This is a class. That's a template. This is a namespace. And that is the name. And so that's really how they all tie together.